In Module 11, Section 4, we will be adding, subtracting, and multiplying radical expressions. Rules in the previous section allowed us to split radicals that had a radicand, which is the number underneath, expression underneath the root, which was a product or a quotient. However, we cannot split sums or differences. Like radicals, or radicals with the same index and the same radicand, like radicals can also be combined with addition or subtraction by using the distributive property. Essentially, we're going to combine the coefficients of like radicals and keep the radical the same. So let's try to add or subtract as indicated. We start with the first example, square root of 3 plus 7 square root of 3. So let's just think about how many square roots of 3 we have. We have 1 square root of 3 plus 7 more. So really we have 8 square roots of 3. We add. We can't really call this the coefficient because the entire term is just a constant, so it is its own coefficient. But if we treat the square root or the cube root like a variable, we're adding the numbers in front of the radical symbol. On the next example, we have 10 square root of 2 minus 4 square root of 2. The square roots are the same. The numbers underneath are the same. We can combine the numbers in front. 10 minus 4 is 6. So this becomes 6 square root of 2. We do not add or multiply underneath the square root when we are adding or subtracting different square roots together. Part C, we have square root of 5 plus square root of 3. While we are taking the square root of each of these numbers, the radicand, the numbers underneath, are not the same, so we cannot combine those together. So when we add or subtract, nothing changes. On part D, something similar is true. We have the square root of 2 plus 4 cube roots of 2. The first radical is a square root. The next one is a cube root. We cannot combine those together. So we just write the expression that we started with. Let's try another example. We need to simplify the radical expression. Now, unlike the last example, we need to first simplify each square root or cube root. In this case, it's a square root, before we can try to determine which radicals are like radicals. So we start by finding the prime factorization of each number underneath the square root, taking out the identical pairs, and then rewriting each square root appropriately. So we start with 75. The prime factorization of 75, we know that 75 is 3 times 25, which is 5 times 5. We have an identical pair of 5s. So we can bring that 5 to the outside with the negative sign that's already there. This becomes negative 5 square root 3. Let's do the same thing with 12. The prime factorization of 12 is 2 times 2 times 3. So we have an identical pair of 2s. We bring the 2 to the outside. This is plus 2 square root of 3. We have a 3 left underneath. And because 3 is prime, we don't even have to try it. We know it's not going to have identical pairs of factors. So we bring down minus 3 square root of 3. At this point, each term has a square root of 3. So we can combine the numbers in front of the square roots. We have negative 5 plus 2, which is negative 3. Negative 3 minus 3 is negative 6. So this becomes negative 6 square root 3. Let's try another example. We want to simplify the radical expression. We have the cube root of 64 plus the cube root of 14 minus 9. So we make our prime factorizations again. The prime factorization of 64 is 2 times 32, which is 2 times 16, which is 2 times 8, 2 times 4, which is 2 times 2. Because we're taking the cube root, we need groups of 3 identical factors. So I have one group of 2's, another group of 2's, and 2 times 2 is 4. So the cube root of 64 is just 4, plus, let's do the same thing with 14. 14 is 2 times 7. So while it does have a prime factorization, we don't have identical pairs of 3 factors that we can pull out. So this remains the cube root of 14 minus 9. We combine like terms, which in this case will be the 4 and the negative 9, and that becomes negative 5 plus cube root of 14. In the next example, again, we want to try to simplify the radical expressions. We assume that all variables are positive. So we start with the first radical expression, 45x cubed. We take 45 and write its prime factorization. 45 is 5 times 9, 9 is 3 times 3. So we have an identical pair of 3's. So we bring a 3 to the outside where there's already a 3, so we multiply those 3's together. 3 times 3. We have a 5 left underneath the square root. Now let's look at the variables for that first radical. We have the square root of x cubed. Remember, long division is for the x's in the first part. The exponent divided by the index. 2 goes into 3 one time with 1 remaining. This means we bring 1 factor to the outside, we leave 1 factor on the inside. So this reduces to 9x square root of 5x. We've dealt with only the first term so far. If we look at the second term, we have a 5 underneath the square root, which we should already know from the first term isn't going to factor down or pull out. We have an x underneath the square root, which has an exponent of 1, so it can't do anything. 2 can't go into 1 any times. So we bring down the second term, x square root of 5x. So if we look at the variable and the radical, we have an x square root of 5x, x square root of 5x. Now we can add the coefficients. I have 9x square root of 5x plus, remember this isn't understood, 1 square root of 5x. So this becomes 10x square root of 5x. Here we have an example with fractions. It doesn't matter that we have fractions. We're going to work it the same exact way. Every radical involved, we try to simplify first. So we start with the square root of 45. And just like we saw on previous problems, 45 is 3 times 3 times 5. So it has a pair of 3's that can be pulled out. So we can rewrite this as 3 square root of 5 over 4 minus square root of 5 over 3. The only difference between this example and previous examples is because we have fractions, we need a common denominator before we can go any further. So we find the least common denominator, which is 12, which means we need to multiply the second fraction by 4 over 4, the first fraction by 3 over 3. And when we do so, when you multiply a term or a factor with a square root, do not multiply the whole number on the outside into the square root. For example, in the first fraction, 3 times 3 square root of 5, we'll multiply the 2 3's that are on the outside. 3 times 3 is 9 square root of 5 over 3 times 4 is 12 minus, in the second fraction, square root of 5 times 4. Because 4 is on the outside, we will keep it on the outside. So 4 square root of 5 over 12. In the numerator, because we have the same type of root, the same numbers underneath the root, we can combine the coefficients, the numbers out front. 9 minus 4 is 5. So we have 5 square root of 5 all over the same denominator, 12. Now let's try to multiply with radicals. We're going to do this just like we had variables for the most part. We're going to FOIL, and then we're going to simplify if possible. There are FOIL arrows first, outer, inner, last. Our first product, we have 3 square root of 7 times square root of 7. Our outer product, we have minus 3 square root of 7 times square root of 2. I just went ahead and put my negative sign in the front. Inner product, minus 8 square root of 2 times square root of 7. And the last product, we have 2 negatives, which will make that become positive. So plus 8 square root of 2 times square root of 2. Let's multiply numbers on the outside of the square roots and numbers on the inside of the square roots. So here, in the first term, we have 3 square root of 7 times 7 is 49 minus the second term, we have 3 square root of 7 times 2 is 14. Third term, minus 8 square root of 14. And the last term, plus 8 square root of 2 times 2 is 4. Let's break down any square roots that we possibly can. Starting with the first term, the square root of 49 is 7, so this becomes 3 times 7. Now, because we have square root of 14 twice, I'm just going to write the prime factorization of 14 at the top of the page, which is 2 times 7. Because we don't have any pairs of identical factors, it will not simplify. So we will just keep those terms as the square root of 14. So minus 3 square root of 14 minus 8 square root of 14 plus the square root of 4 is 2. So the last term becomes 8 times 2. We continue to simplify. 3 times 7 is 21. We can combine our like radicals in the middle. That will give us minus 11 square root of 14. And at the end, 8 times 2 is 16, so plus 16. We now combine our like terms without the radicals. 21 plus 16 is 37. This becomes 37 minus 11 square root of 14. Let's try another example. 7 square root x plus 4 times 6 square root x minus 4. So we FOIL again. First, outer, inner, and last. The first multiplication, we have 7 square root x times 6 square root x. The outer will be minus, I just bring my sign to the front, 7 square root x times 4. And the inner plus 4 times 6 square root x. And the last, 4 times negative 4 is negative 16. We can just go ahead and write that down. As we continue to simplify, we go back to the first term. 7 and 6 are on the outside of the square root. 7 times 6 is 42. Square root of x times x is x squared minus. The next product, we have 7 times 4 on the outside, so 28. Square root of x. The third product, 4 and 6 are on the outside, so plus 24 square root of x. And the last product we've already worked out, we just bring down the minus 16. Let's continue to simplify. Square root of x in the second and third term will not simplify, but the square root of x squared is just x. Anytime your index and your exponent match exactly, they undo one another. They cancel each other out. So we're left with 42x. We can combine the second and third term to make minus 4 square root of x. We're now minus 16. And we see we have no like terms left. We have an x, a square root of x, and a constant. So we are finished.